Hi everyone! Today we're going to talk about how to use limit laws, along with the graphs of two functions, to solve a few limit problems. To complete this problem, we'll first identify the laws we need to use, apply them to our limit problems, and then use information from the graphs to solve each problem. Let's take a look. In this particular problem, we've been asked to use limit laws and the graph that we have of f of x and g of x to evaluate each of these three limit problems. If we look at part A, we can see that we've been asked to find the limit as x approaches -2 of f of x plus 5 times g of x. And the first thing we need to do is identify which limit law we're going to be using. And what we know about limit laws is that the limit of the sum of two functions is the same thing as the sum of the limit of each function individually. So what we can do, and all that basically means, is that we can break apart this f of x plus 5 times g of x and take the limit of each one individually. We don't have to somehow find the limit of the two of the combination or the sum of the two functions. So we can change that into the limit as x approaches -2 of f of x plus the limit as x approaches -2 of 5 times g of x. And we haven't changed the function at all. Limit laws tell us that we can do this. Limit laws also tell us that the limit of a constant times a function is the same thing as the constant times the limit of that function, which means, again, all that means is that we can pull the 5 out in front of our limit over here. So instead of taking the limit of 5 times g of x, we can take 5 times the limit of g of x by itself. So all we're doing here is using limit laws to help us simplify this limit problem. So now that we've separated these and pulled the 5 out in front, you can see that we're just taking the limit as x approaches -2 of f of x and the limit as x approaches -2 of g of x, which is now totally doable. So the limit as x approaches -2 of f of x, we can look here at our function f of x, and we see the point here, -2, right? This would be the line here, x equals -2. So as we approach x equals -2 of f of x, we get to this point right here, which is about at y equals 1, right? We have the point here, -2, 1. So we know that the limit as x approaches -2 of f of x is 1. So we can go ahead and substitute for this entire expression here, just the value 1. Then we have plus 5 times the limit as x approaches -2 of g of x. So we can see here that as we approach -2 for g of x, we get about this point right here, which we'll call -2, -1, right? Because that's about at y equals -1 there. So we'll substitute for this entire expression, limit as x approaches -2 of g of x, we'll substitute a -1. And now we can just simplify this to 1 minus 5, and we get -4. And that's our answer for part A. Part B is the limit as x approaches 1 of the product of f of x and g of x. Again, we'll use another limit law, which tells us that the limit of the product of two functions is the same thing as the product of the limit of the individual functions. So again, we can split this apart to say the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. The thing that we have to realize about this problem is that we can compute the limit as x approaches 1 of f of x, because we can see the line here, right? X equals 1. So if we look at f of x here, we have about, let's call it 1, 2 would be the point on f of x. But if we look at g of x, we can see that we have a different left-hand limit than a right-hand limit. Our left-hand limit is going to be this point, right? As x approaches 1, we have the point 1, -2. And our right-hand limit, as we come this way, the point is 1, -1. So we have a different left-hand limit than the right-hand limit, which means that we have no general limit, that the general limit does not exist. And so this whole concept here of the limit as x approaches 1 of g of x, we can't find. We can find separate left and right hand limits, but we can't find a general limit for g of x, which means that this limit here does not exist, and we'll call it dne. So because we can't take the general limit of g of x, we can't make a substitution for this and find the general limit for f of x as x approaches 1. So this limit here does not exist. We can find separate left and right hand limits, and we can do that here. So we can say the limit as x approaches 1 from the negative side or from the left of f of x times the limit as x approaches 1 from the negative or left-hand side of g of x, and then we can go ahead and make substitutions. So for f of x, as we approach 1 from the left-hand side, so we're coming up this way, and either way with f of x it won't matter, but we approach the point or the line y equals 2, we approach y equals 2, so we're going to go ahead and make a substitution of 2 for limit as x approaches 1 from the left-hand side of f of x. The limit as x approaches 1 from the left-hand side of g of x, we already know to be -2. So we plug in -2, and the answer here we get is -4. But in contrast to that, if we take the limit as x approaches 1 from the positive or right-hand side of f of x times the limit as x approaches 1 from the positive or right-hand side of g of x, we'll get, again, for f of x, we approach the same point here, right? There is a general limit for f of x, so we get 2. But with g of x, we already know the limit here is -1 because we approach that -1 coordinate. So we'd plug in -1 here, and we would get a value of -2. So this would be, we'll call it the left-hand limit, and this would be the right-hand limit, which we can compute even though we're taking the product of these two functions, but we can't compute the general limit. When it comes to part C here, we can see that we have the limit as x approaches 2 of the quotient f of x divided by g of x. And the limit law that we want to be aware of is that the limit of a quotient is the same thing as the quotient of the limits. So we can simplify that function, and instead of taking the limit of the quotient, we can take the limit as x approaches 2 of f of x, all divided by the limit as x approaches 2 of g of x. So that's how we can simplify that function. In the same way we had trouble with part B here, we're going to have some trouble with part C because we never have a problem evaluating this type of a limit problem except when the limit as x approaches 2 of g of x here, or whatever's in the denominator, is equal to 0. So as we can see, when x approaches 2 of g of x, we're looking at this point right here. This is x equals 2 on g of x, and as you can see, the value of g of x at that point is 0. The problem with that is that regardless of what the limit is for f of x at that point, right, of f of x, regardless of what that is, the limit as x approaches 2 of g of x is 0, and we can't divide by 0. So we're actually not able to take this limit, and we have to say that this limit does not exist because g of x is 0, and therefore this quotient here would be undefined at as x approaches 2. If g of x were not equal to 0 as x approached 2, then we would just be able to make a substitution for limit as x approaches 2 of f of x, and another one for limit as x approaches 2 of g of x, and we would simplify this fraction, and that would be our answer. But in this case, because we have 0 in the denominator, this limit does not exist. So I hope you found that video helpful. If you did, like this video down below and subscribe to be notified of future videos.